Welcome to the DUCO Collaborative Robot Training course. Multi-collaborative robot supports profinet industrial bus communication. When the PLC communicates with the robot profinet, the robot acts as a slave. The communication interface of the robot control cabinet is LAN 1 interface. The cycle of DUCO robot profinet data interaction is 8 milliseconds. The first step is hardware wiring. Connect the PLC communication network port with the LAN 1 interface of the robot control cabinet with a network cable. The second step is to set the Internet Protocol address. Click on the username, System Settings, and Network Settings, and the interface will jump to the Management Center. Click on the settings of the Wired Network Interface, Card LAN 1 interface. Enter the Internet Protocol address assigned to the robot. Save the project after returning to the robot interface. Step 3 PLC configuration, Cymatic S71200. 1. Our configuration method. The following takes Siemens PLC as an example to demonstrate the configuration process of the profinet interface using TIA14 software. PLC add the required CPU. Import DUCO robot GSD file. CUP establishes profinet communication with DUCO robots. Modify CPU and DUCO Internet Protocol addresses. Manually set I/O update time. Download it to the physical CPU and observe the PLC status online. Profinet is now connected successfully. The fourth step of communication testing. Manual communication test. Input and write values for robot functions in PLC software. View the corresponding registered input value in the robot interface register page. Input and write values to the robot bool in the PLC software. View the corresponding registered input value in the robot interface register page. Input and write values to the robot word in the PLC software. View the corresponding registered input value in the robot interface register page. Input write value to robot float in PLC software. Write values in the robot register page bool output, word output, floating output. Configure the function output signal in the robot register page. Check the corresponding address signal status in the PLC software. Write value in robot register page bool output. Check the corresponding address signal status in the PLC software. Word output write value on the robot register page. Check the corresponding address signal status in the PLC software. Float output write value on robot register page. Check the corresponding address signal status in the PLC software. Programming communication test. Write the program on the PLC side to realize the start of the main program of the PLC stop and dial robot subroutine and subroutine B in turn. The robot side is first in the interface register function input page. Configure function input 1 to run main program respectively. Function input 2 is configured to stop program. Then configure function output 1 as program running status on the function output page. In the program page, create a new main program, subprogram as SUBA, subprogram B SUBB. Then drag a script function block into the main tree. Use write_reg command to reset registers bool output 1 and bool output to 2 false. Realize the function of initializing output register after program startup. Continue to drag in the while function block to configure its parameter to loop all the time. Realize loop execution of main program. Drag in the script function block to reset registers, bool output 1 and bool output 2 false again. The purpose of this operation is to reset the output register before each loop execution. Drag in the wait function block and configure the parameter as conditional expression. Add a conditional expression to bool_reg_ in 1 == true or bool_reg_ into == true. Realize the waiting of PLC input signal. Drag in the if function block and configure the parameter as conditional expression. Add else function block. If edit conditional expression to bool_reg_ in 1 == true. Else if edit conditional expression to bool_reg_ into == true. Then, in the if function block undefined, drag the wait function block to set the delay of 3000 milliseconds. Drag in the script function block and edit the conditional expression to bool_reg_ out 1 == true. Drag in the subprogram function block and select the subprogram SUBA. Drag the wait function block into the undefined section of the else-if function block to set the delay by 3000 milliseconds. Drag in the script function block and edit the conditional expression to bool _reg _out 1 equals true. Drag in the subprogram function block and select the subprogram sub. Save the program when complete. The above operation realizes the main program according to the bool input 1 and bool input to signal to the subroutine, btransfer. Finally, in order to facilitate the observation of the subroutine's allocation, add message function blocks to subroutine asuba respectively. Enter the message successfully called subroutine. Add message function block in subroutine B subb. Enter the message successfully called subroutine B. Finally, enter the function into the running program in the register and select main program. The program is written and the test is run. Just start the PLC program in the software and observe the status. If you use scripting to rewrite the above program, the instructions for reading and writing registers should be replaced by write_reg and read_reg. Read_regnum type in _out function first argument is the internal register number. The second argument is the register type. 1 is the bool register, 2 is the word register, and 3 is the float register. The third parameter is input. Output 0 for input, 1 for output. Returns true or false when the read register is of type bool. The return value is number when reading registers of type word and float. Write_regnum type val function first argument is the internal register number. The second argument is the register type. 1 is the bool register, 2 is the word register, and 3 is the float register. The third bit parameter writes different values depending on the register type. Script programming implementation. The program is written and the test is run.